We're going to find the first 5 terms of the sequence defined by this expression here. And notice right away, get your attention, you've got -1 to some power. We'll start with n equals 1, and then 1 plus 1 is 2. It's an even power. So this sequence is going to start with a positive term. So let's start here with n equals 1. So we'll put 1 right into here, 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 and here. So we will get a sub 1, our first term, being -1 to the 1 plus 1 times 1 over 2 times 1 plus 1. Now, this is going to be -1 squared, which is going to be 1 times 1 over 2 times 1 is 2 plus 1. We've got a 3 here, so this is just 1/3. Now, when I go to n equals 2, I already know that that term is going to be negative. How do I know that? Because before I started making any computations at all, I looked at that alternator up here. Let's see for sure. All right, so when n is equal to 2, we're going to get a sub 2 equals, now where did I get that 2? Just that 2 right there, I'm putting here, 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 and here. So we will get -1 to the 2 plus 1, which is 3. 3 is odd, so I got a negative number to an odd power, so that's going to be a -1 times, now keep going over here, it's going to be what? Putting in 2. 2 times 2 plus 1, so this is going to be 2 over, what do we get here? 4 plus 1 is 5, so what we get is -2/5. Let's go for n equals 3. So when n is equal to 3, we're going to get a sub 3 equals -1 to the 3 plus 1. Now I know that I started off here, right? We started off with what? Positive, alternated to a negative. This should be positive. Sure enough, 3 plus 1 is 4. -1 to an even power is positive. Put a 1 there times. All right, now we'll put the 3 in here. 3 over 2 times 3 plus 1. So this is going to give us 1 times 3 over 2 times 3 is 6 plus 1 is 7. So we get 3/7. Now, as we do this n equals 4, let's just stop for a minute and see what's happening. See if we can see a pattern here. Go back up to our dividing formula. We already know that we're going to see an alternator here. Fine, but let's look over here. What are the numerators? What are the denominators? Well, the numerators, that numerator is just going to match my term number. And does it? Let's see. For A1, we got a 1. For A2, we got a 2. For up here now, for A3, we got a 3. What about these denominators? Now look at that denominator. This is the term number, so what do? You double it. Now if you double something, it's even. If you add 1 more to it, it's odd. So this is always an odd number. And what is it? It's 1 more than twice the term number, right? N is the term number. So look what's happening. It's 1 more than twice the term number. So 1 more than twice the term number. So at 1 more than twice 1 is 3. When n is 2, twice n is 4, 1 more is 5. When n is 3, twice n is 6, 1 more is 7. When n is 4, all right, so what are we going to get at n equals 4? Let's just write this term. Now it's going to be what? Look at our alternators. We've got positive to negative to positive to negative. So this is going to be A4 is going to be negative. And then what did we say here? The numerator matches the term number. This is 4. And the denominator is 1 more than twice the term number. Twice the term number, twice 4 is 8. 1 more is 9. And then n equals 5. So what do we get for A5? A5 is going to be, all right, alternator. Back to begin. Positive, negative, positive, negative. This is going to be positive. And the numerator matches the term number. The denominator is 1 more than twice the term number. Twice the 5 is a 10, 1 more is 11. So here's our 5 terms. first 5 times. 1/3, negative 2/5, 3/7, oh, let's write a 7, negative 4/9, and 5/11.